Well, good day. So today we're working on this 1990 Camaro. It's got the 5-liter Tuned Port, but it has a misfire, a random misfire, and of course it's too old for misfire counters or misfire codes. It's only got 29,000 kilometers on it. Car is immaculate. It's hardly driven. That's probably part of the problem. I tried to isolate the mist to a specific cylinder and couldn't. So I thought I'd take a look at the distributor cap, and you can see the towers on the distributor cap are all oxidized. But look inside the distributor at the oxidation on the distributor plate. This thing's going to need the pickup wires cleaned. I bet you that's what's going on. I bet you the pickup coil terminals underneath there are all corroded. So we're going to take that off and have a look at it. So there's the distributor module taken out. These are the pickup coil wires. This is an AC signal from the magnetic pulse generator, and you can see the oxidation on the terminals. The distributor base plate needs to be cleaned. It has to ground through this. There's no dielectric grease left on there, so the module might overheat. I've blown it off somewhat. These terminals need to be cleaned as well. I've got a new cap and rotor coming. I'm going to clean these terminals. Well, there's the module all cleaned up, but I'm having difficulty getting this rotor off the shaft. Yeah, a little slide hammer would work great, but you can't really pry against the pickup coil underneath it. Otherwise you'll damage it. I can't pull it off. It is rusted onto the shaft, which is typical. Let's see what I can figure out. So I decided to take the distributor right out of the car because it's just easier. So I marked the position of the rotor, and it just happened to be pointing straight towards the front of the center line of the engine. We're going to reinstall it in the same spot. Oh, I got a little... Anyways, hopefully I can get this rotor off of here. I have to break it and clean these contacts and clean this surface here. You can't pry on here because you'll damage the reluctor. And if you I put a block of wood on the plate here and pried up on it, but I could feel that the distributor housing is going to bend. So I squeezed the rotor in the vise until I broke the plastic. You can see how rusty it is inside there. There's no way that was coming off inside the vehicle. But nevertheless, we'll clean this shaft up with the emery cloth. I would put in a complete distributor because we need a cap and a rotor, but it's not available. Well, I shouldn't say that isn't available. There is one available, but it's a cheap Chinese knockoff, so I don't trust the quality of it. And a good one is several weeks away. So there's supposed to be a gasket on here, and it's not in there. And it didn't fall off when I took the distributor out. Normally it stays on the distributor, and it's not down inside here. And I don't see it anywhere, so we're going to have to find a new gasket for that. That means that somebody had this off. I noticed when I started working on here that there's a little aluminum cosmetic plate that bolts on with 2 screws here that normally sits over top of the distributor. That was missing, so somebody's been in here looking at stuff. Don't know what they did because they didn't have the cap off. They would have seen a catastrophe in there. Dielectric grease under the module, between the module and the base to transfer heat. And I put some dielectric grease on the distributor shaft after I cleaned it to kind of keep it from rusting. And then we're waiting for the cap and rotor. We're going to put this back together. So it's just a little round paper gasket. Found one in the gasket set that I had saved from an engine rebuild some time ago. This has been a while since we've had distributors. So there's the distributor back in, lined up with the static mark that was on there from the original. And we got to set the base timing, which involves connecting the timing light to number 1. This is number 1 here, and it's 1, 8, 4, 3, 6, 5, 7, 2. Turns clockwise looking at it from the top. But to set the base timing, there is a set timing connector, and on this car it's right here.
right beside the AC accumulator. So we're going to start it and run it up to temperature, then we're going to disconnect that and then check the base timing.
Not sure if this is going to show up on the video. No, not really. Maybe if I had a higher refresh rate, 30 frames per second. But advancing the timing mark back to 0. I'm at about 5 degrees, and that's with the set timing connector plugged in. So I'm going to unplug it. So you can hear it's idling significantly slower. Let's reset it. Yeah, I'm actually way retarded. So I need to rotate the distributor opposite the direction that it turns. So we need to turn it this way. I got it too tight. And the timing's supposed to be 0. And right now it's at 2 degrees retarded. I usually set it about 2 degrees advanced. That's at 0 right now. I don't know if it's going to pick it up, but it's right in the wide knot. There we go. So we tighten it down there. So disconnecting that set timing connector will set a code 42 for EST circuit failure. So I plugged it back in, but it should go off when I start it this time. No, maybe I'm gonna have to clear the code. We'll see what the timing's running at now. So if I bring the timing back to the 0 position, it's running at 15 degrees advanced. That should be what the scan tool tells us when we hook it up, because I got to hook it up to clear the fault code. So I got the scan tool hooked up to it. I got to put the adapter in it to convert it to OBD2. And there should be a code 42 in history. The check engine light is off right now. Yeah, electronic spark timing code. So SureTrack has a starter motor causing that? Really? Okay. Clear codes. Should be gone now. Yeah, GM allows you to clear the codes while it's running. And let's look at data. Remember, the timing light said the timing was at 15 degrees. So let's see if you can see that in the data list. Knock retard is 0. Spark timing 12 degrees. 11, 12, 14. The system varies the spark timing to stabilize the idle. The car seems to be running nice and smooth now. I'm going to take it for a road test, but I'm 99% sure this is going to be fine now. OBD2 compliant vehicles display fuel trim correction as short-term and long-term. Prior to OBD2 legislation, GM used to display short-term as a numeric number of integrator 128 and block learn 128. 128 means there's no correction being made above and beyond what the system would theoretically require given the current RPM and load combination and temperature. So a number of 128 here indicates that it's running at 0% correction. Positive numbers higher than 128 indicate that fuel is being added. So it goes to 255, plus or minus 10%, which is roughly 12. So anything from 140 down to 100 and, I hate math, 12 or 13 points less than 128 would indicate a reasonable correction, short term and long term.